Hello everybody! Today we're going to be going over the basics of the Grimport language. So, after opening up the Grimport editor, let's create a new script by clicking down here. We can create a script either for our website or keep it local. For this video, I'll create a script for our website. I'll call this script video2 file. And as you can see, when I click save, it will appear on the left. So, how do we use variables? Well, much like other programming languages, variables are boxes that can store data. I can create a variable, I'll call it storage here, and I can put some data into it, like table. That's a string, by the way. I can also put other things into it, like numbers, lists, and booleans. Now, if I want my variable to display its data, then I'll have to use the console function. This function will run some pre-made code elsewhere and display the data when I run the script. This function takes 3 arguments. First, there's what we want to display. Next is whether or not we want to have a line break. That is, if I run several console functions, then with line breaks, the displays will be on different lines. Finally, this is whether or not we want to show the thread identification number. So right now, we don't really care about these arguments. Luckily, they're optional. We can tell they're optional because the variable names start with an underscore. So I'll just remove them, and we can launch scripts by clicking up here. As you can see, the console appears, and here we can see the text up here. This is normal, because the console function outputs the data in the variable called storage, and the current data in the variable called storage is the text table. To use some terminology, table is the variable's value. I can also modify this variable by overriding it with something else, like chair. If I do this, you can see that the value has been overwritten. I can also perform some operations. I can use addition. I can write, for example, table plus chair, and we can see that the addition operation concatenates 2 texts together. Because my variable originally contained table, I can replace this here with a variable's name. This won't be a problem in this language, because what will happen is that the storage plus chair will be executed first, then stored in the storage variable. In other words, the right side will be executed first, and then it will be stored on the left side. Executing the code, you can see that we get the same result. As a shortcut, we can also do plus equals. This does the same thing as variable equals variable plus. If I launch it, here, we get the same thing. We can do the same with numbers. If I replace this text with numbers like 8 and 2, then I can add 2 numbers together. I can subtract them, I can multiply them, and I can divide them. We can also mix different types of values. Here, this is a number, and this is a string. If I attempt to mix these 2 together, then Grimport will automatically convert this 8 into a string. The string is prioritized over the number. Now, often, when we deal with numbers, we'll want to increase the value by 1. We can do this with plus equals 1, but we can do it even more simply with plus plus, double plus. If I divide 2 numbers, I get another number. This result, by the nature of division, doesn't have to be a whole number. This here is a modulo. It gives the remainder of division, as seen here. Let's go back to strings. As an aside, adopt good practices and name your variables something informative. For example, calling a variable the name variable is not informative. It doesn't tell us its goal or value. and it should at least do one of those. Here, for example, I'll call this variable string to insert because it's going to be a string that I'm going to insert. I'm going to show you yet another way to insert text. I can use the $sign to indicate the variable I want to insert. If I execute this, you can see that it's been inserted. This is the equivalent to this. As you can see, the spaces inside of the quotation marks appear in the output. However, the spaces outside do not. I can put many spaces here. I can even go to the next line and it'll still work, as shown here. But what if I want to go to the next line of my text? How do I get my output to show something like this? Well, we use \n. This is what we call an escape sequence. Note the use of the backslash for the letter. That's what indicates that this is an escape sequence. Note that the backslash also only takes the first character immediately after it. I can do /t, for example, for an indent. I can also use the backslash to cancel the effects of a symbol. For example, if I place the backslash here before the $sign, I cancel the $sign's ability to replace a variable. And when I run the code, all I will get is the literal string $sign string to insert. Now, what if I want to put a backslash? Something like this. Well, again, the backslash cancels the effects of something. So I can put a second backslash for the backslash, which will cancel the effects of the second backslash, as seen here. See, the backslash appears. Alternatively, I can put single quotation marks. This does the work of the backslash, but also has this other effect of having the apostrophe end the string prematurely. No worries, I can always backslash the apostrophe. If I want to not have to do /n, I can have triple quotation marks, like so. Let's move on to Booleans. These are words that tell us if something is true or false. Let's define two variables, is a boy and lives in Paris. If I print to console, I can see that this is false, because I've defined it so. Now, if I want to check that my two variables are true, I can use the and operator. As you can see here, it's false, because one of them is true and one of them is false. I can also use the exclamation point operator to take the inverse of the Boolean. That is to say, if this is false, then with the exclamation point, this is true. And vice versa. If this is true, then if I take the exclamation point, then this is false. And we are testing whether something that is true here and something that is false, but I take the opposite, so something that is true. True and true is true. If I want to test whether or not at least one of the variables is true, I can use this operator. Here, this one is true, so the output would be true. Here, both are false, and so the output displays false. Now, let's say that I want a variable. We'll call it first name, and say that it takes François if lives in Paris is true, and Marc if not. Well, we can use tertiary conditional operators to test this. Using the question mark and colon, I can write this to test the conditional. Because lives in Paris is false, I get mark, as seen here. To generalize, if my condition is true, then this is executed. Otherwise, this is executed. I can also use this tertiary operator to test whether or not a variable is set. If I have first name chosen set to Terry, well then first name will take Terry. If the value of the variable is empty, then it will take Mark, as shown here. In a way, the variable is false when its value is the empty string, and true otherwise. I can shorten this test to question mark colon, which acts as the variable is defined operator. The empty string is not the only way to mark a variable as false. There's also the Boolean false we just saw. There's 0, and then there's null. Let's talk about null actually, because that's not quite the same thing as an empty string. See, an empty string means that I've declared a variable's value to be empty. In part 1, I said that null means the default option. Well, the default here is nothing. In other words, I haven't declared anything. Nothing has been declared. That's not the same thing as an empty string has been declared. We can also use null in functions. Consider the console function we've been using. If I put null here, then it will take the default values, as seen here. This is useful for when we want a default value for some arguments, but not some others. If I want to display the thread ID, then I need to declare this variable, and this is not a valid way to write. Since I don't care about what this argument is set to, I write null, and then true. As you can see, this second argument will take the default option, false, and since the third argument is true, then the thread ID is indeed displayed. For a real-life use case, consider when we're updating a product's information. If we don't want things to be updated, then we put null next to it. For example, if I don't want to update the price, I put null next to it. Let's move on to lists. If I want to have multiple values in a variable, then I can use lists. I can set a list, let's say price, height, and weight. Now, an important thing to note is that this list starts at 0. So, this is the 0th element, this is the first, and this is the second. That's how it usually is in most programming languages, and Grimport's is no different. If I get the first element, I thus get height, as seen here. If I want to add something to a list, I have to use pointers. Of note, this is one of the rare times we'll ever use pointers. I can add quantity, as seen here. Likewise, if I want to delete something from a list, I can use remove. I'll remove price. As you can see here, price has indeed been removed from the list. There are also maps. These will associate one item to another. For example, if I take the list and I associate some values to these elements, then instead of using numbers, I can use the name. In a sense, I've named the index. If I run the function, we can see that I get the correct value. I can also use negative numbers to start from the end. -1 here will give me the weight. Let's talk about functions. We've already used two, console and get, and if I want more details on these functions, I can highlight the function and click this button up here in the top right. This will take you to the page for it. If I don't select any function, I just get the list of all functions. I can use the search function to search for specific functions. If I want to look beyond the function name and also the description and whatnot, I can press this button. The functions are also sorted into groups, so if you're unsure of what keywords to use, you can look at specific groups of functions. These functions are already coded, but we can also create our own functions. I can use def to define my function, write some code, and execute it. Oh, but wait, nothing happened. That is intentional. For a function to be run, it needs to be called. For a function to be called, we have to write its name, like so, with some arguments. And if I execute the code, then we will indeed see the function run. Let's talk about local and global variables. If I declare a variable like so, then it's global. You can see that putting the variable in the function, it appears. If, however, I use the def keyword, it becomes local. And when I run it, we get an error. You may notice that this implies that the function is also global, and should be correct. It only exists within the initial script. If I want my function to be global, or super global as it's called, then I need to use closures. The syntax looks like this. Then we call this function setGlobal. So this function will now work in initial, but also the other scripts. This concludes the second part of this tutorial.